Hello, good evening to one and all. I welcome you all to the 53rd webinar of the series Predictive Healthcare Analytics using Python, organized by IEEE Malabar subsection, jointly with IEEE Malabar Hub and IEEE ME Engineering College Student Branch. I welcome you all to the session. First of all, I would like to welcome our resource person of the day, Dr. Doreen Robin, ma'am. She is the founder and director of Computational Intelligence Research Foundation. Ma'am is also the administrator of Botanical Metric Higher Secondary School. She is a well-known digital trainer who trains different students and faculties of our nation. And I welcome you. I also welcome all the executive members of IEEE Malabar subsection, Dr. Sabik P. Sir, Bindima ma'am, and other executive members. I also welcome all of the participants and professional members who have joined over here. I also welcome all the members from different parts of IEEE sections and student branch over here to the program. A bit before housekeeping before the session, I request all the participants to clear your mics muted throughout the session to avoid unwanted disturbance. You can have your Q&A sessions and other communication with the speakers and the moderators through the chat box. There will be a feedback form circulated at the end of the session. I request all the participants, please ensure you have filled the feedback form to ensure your certificate. And by that, I would like to welcome all the participants over here. We all know we are going through the difficult times in this, and we are all joined over here in the comfort of our homes. I request all the participants to learn from the best we can have over here and stay home, stay safe. Over to you, ma'am.
Thank you. Thank you, Mohammed Musharraf sir of MEA College for having invited me to give the talk on the topic predictive healthcare. Okay, predictive healthcare using Python. Okay, before we start with the session, I hope all of you are students here, students or faculties. Can I have it in the chat? If you're a student, type yes. If you're a faculty, type F on the chat. There are many students here, 93 people are here. All right. Are you a student or a faculty? If you're a student, type S. If you're a faculty, type F. Student S. Yes, only one S, not YES. Yes. Student, the first letter is S, and faculty, you can type as F. Most of you are students. Okay. So I feel always happy to meet students. This pandemic has helped us to meet to each other through these virtual platforms. Next 1 hour, we are going to see about the how to predict a disease or a healthcare analytics. Okay, the topic is predictive healthcare analytics using Python. Listen carefully throughout the session. At the end of the session, by 6:25, we will be playing a live quiz. The questions will be from the talk that I'm going to give. Listen carefully to it. We are going to see who's going to be the winner of the day. All right, I'll start sharing my screen. Once you're able to see in my screen, you can post it. Okay. You're able to see my screen? Yes, you can unmute.
Yes,
yeah, thank you. So I think you'd be having many series of webinars, but today's session, we are going to see about predictive healthcare analytics using Python. See, analytics deals with data. Okay, a data could be an image, it could be a structured form, it could be unstructured form. To start my question for the day, how are you today? I know it's evening, it's 5:30. Can you give your answers on the chat, please? How are you today? Answers on chat, quick. Good. Thank you. Yeah, answers on chat. Fine, thank you. Fine, great, fine. Yes, we have 100+ people. Quick on chat. Great, fine, 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 fine. Good, fine. Yes. So in this pandemic, if I'm able to hear that you're good, that you're fine, we have to praise and thank our God Almighty. All right. So here, I just ask you all a simple question. How are you today? Okay. We have all got good answers like fine, Can you see? Great. Here I can see 2T. There is a small g and capital G. Some of you have given good as GUD. Okay. Fine, ma'am. Fine, miss. Okay. But everything seems to be the same. So when you work with data analytics, just one simple question. Imagine how huge is my data. As a researcher, as a student, okay, I know you belong to any kind of students. You could be computer science, you could be mechanical, you could be ECE, electronics, or you could be electrical, you could be a mechanic, civil engineer, whatever is the stream. Analytics plays a vital role. Initially, only computer science people can code. Now, if you don't know how to do a data analysis, next 5 to 10 years to get a job in any field will be challenging. So this is the prime time for you to equip yourself. Okay, to equip yourself. How are you going to work on with this? Okay, and as introduced by Mohammed Basharaf sir, I'm Dr. Doreen Robin, the founder director. 10 years, for a decade, I was working in different engineering colleges as professor and HOD. Then I started this company called CIRF.co.in. Okay, this is the website of my company. All right, and here what I'm doing here, we work with, it's a Section 8 company. All right, and here we work with basically with big data analytics, okay, machine learning, deep learning, software testing, cyber forensics, and blockchain technologies. All right, so this is my contact number and my mail ID. If you wish, you can make a note of it. Okay, what is data science? Okay, when you take into data science, or if you want to do an analytics, okay, the first step is you need to work with the business understanding. You need to understand the business. For what business? Today we are going to see about healthcare. If you're going to work with agriculture, then it depends on your agriculture analytics. Okay, and then if supposingly if you are going to work, you need to, whatever is an application, if it is climate, the data set changes, but the heart of it is analytics. How are you going to do the analytics is much need of the hour. Okay, so here you've got data mining. Okay, cleaning. How are you going to clean your data? All right, the data exploration. So cleaning data, whenever if you're going to take values directly, okay, say for example, if you're going to take an image, okay, when you're going to detect disease from image, it could be MRI or a CT scan or a PET scan, whatever it is, there will be some kinds of noises. You need to clear out it and you have to pre-process and fetch the data. So first you have to understand what business you're trying to do, and second you have to mine your data. The data set you should take when you're going to develop algorithms, it should be benchmark data set. How are you going to clean your data? How are you going to export? That's what you're going to see after cleaning. It should not have missing values. All right, and you have to clean your data in a proper way and explore it. Exploring is visualizing the data before you develop a predictive model. You need to clearly understand, excuse me, you need to clearly understand what is your data, what are the types of data available, what are the values in data, how it has been scattered, what is the range of data before you do it. Then you go in for feature engineering. Either you can go in for an optimization algorithm or you fetch data from it. It could be feature selection or it could be feature extraction. Okay, you have to find the correlation, how each and every data are being correlated with each other. And then we go in for a predictive model and visualize it, understanding how the results are, the performance evaluation of it. All right. Okay, so these are the basic 7 steps any kind of analytics: understanding your business, mining your data, it should be benchmark data, cleaning your data, clearing out missing values and other stuffs which is not needed, and then exploring your data. What is your data all about? Extracting the features of your data, then predicting a model of it. Okay, predicting the model of your data, and then you have to check out your performance evaluation. Okay, you have to check out your performance evaluation. All right. Okay, so what is data science? Okay, when you take what is data science, it's an interdisciplinary field. Okay, here in data science you use scientific methods. Okay, it's not just a trial and error. You use scientific methods. Okay, you process the data and you use different algorithms and to extract knowledge from it. The data set could be of a structured data set or unstructured data set or a semi-structured data set. And you need to apply knowledge. This plays a vital role. You are going to take an algorithm, you are going to take a data set, extract information. In short, you have to understand whenever you develop a model, you are learning patterns from the data and as actionable insights from data across broad range of application domains. It is learning. How do you learn from each other? Say, for example, if you want to make a friend, you speak with the person maybe after 2 to 3 months. If you love the pattern in which they behave, they speak, is it soothing for you, whether you're able to cope up, then we build a friendship with them. All right, so you learn the patterns, behavioral patterns, to build a normal friendship. Here in machine learning and deep learning, you are going to learn patterns from the data. Data could be a structured data, unstructured data, or semi-structured data. Okay, so basically, when you take data science, there are 3 packages. I'm going to ask you a question. Anybody here worked in Python? Worked in data analytics like Numpy, Pandas, or Matlablib? Or if you have done anything using analytics, you can type yes or no, Y or N. Yes, quick. So 3 Python libraries, we are going to use it for data science. Okay, Numpy, Pandas, Matlablib. Yeah, yes. Some of you said yes, some of you no. Yes, you can put your answers on chat. Just one letter is enough for me, Y or N. All right. Okay, some of you yes, some of you said no. Okay, so when you take this, okay, when you take this algorithm, okay, this Python library, okay, Numpy, it stands for numerical Python. If you want to work with different numerical manipulations, okay, like a Laplace series, Laplace transform, Fourier series, Fourier transform, there are different header files you can extract, because I said in data science you have to extract information from your data set and the pattern of it. So we can use Numpy for scientific methods. Remember I said about scientific methods? Pandas is for data analysis, Python for data analysis. That is what Pandas stands for. You need to analyze the data. So today we are going to take a data set, see how the data set is, visualize the data, and then eventually we are going to you are going to use the Pandas, okay, your data set. So your data set could be of a CSV file or a TSP. CSV, it stands for comma separated values. TSP stands for different, okay, tab separated, or anything, even if it is a text file, okay. If you're working with big data using analytics using Hadoop, if your data set is of Hadoop, or if you're working with SAS, okay, whatever is your data set, okay, you can extract your data set and to visualize, to analyze your data before, for pre-processing, for data cleaning. All right, the first few steps you'll be using Pandas. Okay, listen carefully, students. When you take a data set and when you load into a Pandas variable, it will be converted into the data type called as DataFrame. I repeat it, whatever could be the data set, whatever type of data could be your data set. All right, if you're going to take the data set and load it onto your Pandas, it will be converted into a data type called as data frame. Okay, so that is what Pandas is used for. Okay, and then when you come into Matlablib, okay, when you come into Matlablib, okay, Matlablib is for visualizing the plots. It's for data visualization. There are different visualization tools. Some of you said you are working with it. All right, I hope you should have worked with Matlablib, Seaborn, Bokeh, BOKEH. There are various with data visualization like Python libraries available. So basically the basic tools that you'll be using is called Numpy is for numerical Python, Pandas for Matlablib. Okay, it's sorry, Pandas for Python for data analysis if you want to analyze your data, and Matlablib is used to plotting your data. So, okay, if I'm going to have even 20 lakhs of data, how am I going to plot the data? I cannot read out every values, right? When you see a plot, you'll be able to understand more from it. Okay, and the next A final app package is called a SkyKit. Okay, when you take SkyKit, it stands for SkyKit is the most popular library for machine learning. Okay, whenever you work with machine learning, if you want to develop all the machine learning algorithms are there in this package called as SkyKit. Okay, to do a scientific computation, we go in for Numpy. For analyzing the data, we go for Pandas. For visualizing or for plotting, we go for Matlablib or Seaborn. It's easy to generate charts from your data, whatever could be the size of data. And this is the most important package or library we say. It is called a scikit-learn. Okay, it's the most popular library called the machine learning algorithms are present in Python. Okay, the machine learning algorithms are present in of Python are present in this package called as scikit-learn. All right. Any doubts till now? If you're clear, you type yes, or if you've got doubts, you can type no. Is it okay? Whatever you have done till now, you're able to understand? Yes, no, no, yes, yes. Thank you. Thank you. All right. Okay. Thank you all for your good response. We are move on to the next. See, basically, when you take into analytics, there are 4 types of analytics. The first is the descriptive analytics. The second is the diagnostics analytics. The third is the predictive analytics. And fourth is the prospective analytics. Most of the researchers, our students, you stop with predicting, but most important to optimize your analytics. It could be healthcare, it could be image analytics, it could be climate prediction system, yes, it could be whatever could be the student, how the student's performance, or whatever could be the analysis that you're going to work. This is more important. If you're going to take a sales, okay, how far your sales has reached, how it could be even more made better as it was, it's called prospective analytics. Okay, and this is the basic of all business analytics. You know, everywhere you have a business. Okay, if you go into a sales company, maybe automobiles, okay, or whatever, you can have analytics even when you play games, right? Games, you can do an analytics from the different types of, say for example, there is a lot of analytics that runs even in cricket game. Most of you, I know you like cricket, all right? So different in gaming applications, okay, in climate prediction system, in healthcare, in agriculture, whatever could be the field. Okay, if you're going to work with satellite data, okay, prediction of rainfall, these are the basic for analytics. To understand the 4 types of analytics, I'm going to share an example. Okay, so when we get a fever, to whom do we go to? Answers on chat, quick. When you get a fever, to whom do we go to? We go to a doctor. Thank you, Aroma. Okay. So when you go to a doctor, who speaks first, whether the patient speaks or the doctor speaks about the problem? Whether the patient speaks or the doctor will speak about the problem. Yes, exactly. The patient speaks. So that is called as the descriptive analytics. What happened? So when you take a data set, you need to understand what is this data set is all about. The first step in analytics is called a descriptive analytics, where we visualize the data. What is this data all about? What happened in this data? So you go to a doctor, you tell the doctor, I have got headache, body pain, this pain, that pain, temperature, night, morning, everything. You describe it. So that analytics, okay, I'm just giving you an example for you to understand of, okay, that is an example of descriptive analytics. Even when you work in data science, you take a data, you have to just check it out how the data are. All right. Then what does the doctor do? If he is an experienced doctor, okay, you may say, if these are the patterns of the symptoms, and this could be your disease, all right. Or if these are the patterns of your, what are the symptoms you incur, this could be. Otherwise, he will tell you, you go for a blood test, you go for an X-ray, you go for a CT scan, whatever it is. And why did it happen? Okay, the doctor is trying to analyze why did it happen. So that is called as diagnostic analytics. I'll just show you an example. The same thing, you have to work with data and find out why did this happen. Say, for example, if you take a disease data set, what are the parameters that influence this disease? Okay, whether this patient is infected with tuberculosis or not, whether this patient is infected with COVID or not, whether this particular patient has got cancer or not. Okay, diagnostic analytics. And then after getting the results of your maybe whatever is the test, the doctor will predict after seeing it. You can see from your report, blood test, or whatever diagnosis, he will say, this is because of this disease. Okay, that is the predictive analytics. And after the doctor predicts the analytics, what he writes something on a paper, what it is called as. Your medicines he writes on a paper, what it is called as. It's called prescription. Thank you. So then he gives you a he gives you a prescription which carries the medicine which will eradicate the fever. And they say it will take 3 days, 5 days, it's a viral fever water. So it's called prescriptive analytics. Even thank you all for good answering. Same thing works in analytics. Okay, first from your information, the insight, then you go for diagnostics, you develop a predictive model that is insight, and then you need foresee it. So then the doctor says you can come and see me after 5 days, or he says even after 5 days it will get over. All right, different types of analytics. So even when you work with data science, these are the 4 types of analytics. The first is the descriptive. What we have to take a data set and check what happened. Then diagnostics, why did it happen? You need to understand what are the features influence this disease, what are the important features. That is what we say, right? In a feature engineering, we do the feature extraction and the feature selection. Then we develop a model which will say, even if the patterns of, say, for example, if the diabetic patient, if the sugar level of this type, then we say is diabetic. If the sugar level of the patient is like this, then is a non-diabetic. Okay, learning from the patterns, okay, different patterns, okay, you understand it, right? What will happen? Okay, what will happen? And then this is the most important, prospective analytics. Make it happen. If you're making it happen. Okay, able to understand the 4 types of analytics? I just gave you an example of the doctor, but this is how you have to work with any analytics. Okay, so when you see here in predictive medicines, okay, we are going to see about healthcare. 80% of the hospital leaders, okay, believe the future of care could be significantly improved using predictive analytics. Before you go to a doctor, if a scan has been taken and then says this could be your disease, or next 5 years you could be infected with this disease, yes or no. Okay, so different data are to be analyzed, and 31% of hospitals have already started using more than a year. And this pandemic has influenced. How many of you have experienced maybe during the pandemic situation, right? The doctors all came on video call for checking the patients. Yes or no? Yes or no? Answers on chat. Okay. Can give you answers on chat. Yes, yes, thank you. So see, then he predicts it, okay, because of this pandemic. So now when you come into the predictive analytics in healthcare is one of the most important domain for predictive analytics, okay. You develop a predictive model using historical data, whether this patient is a heart patient or a diabetic patient, is a BP patient, okay, learns data from it, and you need to underline this word, which is called finding patterns, and generate accurate predictions. Say, for example, if I'm going to give, mobile application also is launched for the same. I'll be discussing about that. That's right. Okay. So finding patterns and generating accurate predictions from the model. Okay. So that is called a predictive analytics. When you take in healthcare from historical data, the family patterns. Okay. The next one we are going to see, it finds a correlation and association of symptoms. Okay, whether these factors are correlated or not. Okay, finding the habits, whether he's a smoking habit, drinking habit, or not having a habit. Okay, what are the diseases, and then make meaningful prediction. So you have to find the various correlations, okay, and associations of symptoms, finding habits, all right, and then make. It's a very important role in improving the patient's care, okay, the chronic disease, okay, whatever it is, and increasing the supply chain. It could be into parametrical logistics, okay, and other such. For every, even if you want to find whether the particular disease, now you know what is of more demand, vaccination is of more demand. So from the inventory, it could say if so many people are getting vaccinated per day, then there will be demand of these much of vaccination in the further coming days. Lot of AI models could be developed for any application. Okay, when you could take into any application, there is a huge demand, especially in the healthcare. Okay. And now, population health management is a very important topic in predictive analytics. Okay, so how is the health of the people there? You know, this COVID has made health management is more important, right? Yes, so it's data driven, focusing on prevention of disease and how it could be focused onto the society. With data science, hospitals can predict the deterioration of patients' health and prevent preventive measures to start early treatment. Okay, that's what even in COVID they say. When you get a disease or little symptoms, meet the doctor. Okay, predictive analytics makes important in monitoring the role of logistics supply of hospitals. That's why I said about the vaccinations, other things. All right, and now we are going to see. I don't know how many of you want to become a data analyst or data scientist. If you want to become you are all students, right? If you want to become a data analyst, type as DA. If you want to become a data scientist, type as DS. Quick on chat. Okay, data analyst, data scientist, whatever it is, there is a huge opportunity for both. All right, so now we are going to see what is the difference between data analyst and data. So this data analyst, okay, so they take historical data. First few steps are done by data analysts. Then they do the basic programming, they make modeling, and they're less paid and less experience. Any starter you can start working with data analyst. But data scientists, okay, data scientists, when you think they are paid more, okay, and you develop a predictive model. And if a new model, a new web data you give, your machine learning model or a deep learning model will predict and say what it is. Okay, advanced programming. Okay. Okay, advanced programming or feature projection. In the future, how it will look like. Okay, as Mohammed Musharraf sir said, okay, a mobile application has come. So IIT Mandi, okay, IIT Mandi developed an artificial intelligence-based monitoring application for COVID-19. Okay, when it was released, February 4, 2021. Okay, in addition to the quarantine management, this application also serves as an unbreachable mobile platform for normal mobile users, even non-COVID, okay, to take how they are used. Okay, so IIT Mandi, okay, they've developed an AI-based monitoring mobile application for COVID-19 patients. So this is, so when you take data science in healthcare, you can work with genes, genomics, okay, the data management. All right, the virtual assistant, that's what you all said, even from mobile doctors also, they started drug discovery. Even if you're very good, you can find it out what is the patterns of COVID virus and what are the different drugs could be given to it in collaboration with them. So you can start even in less than seconds, the different permutation combinations of drugs will be given. Then after really testing, we will know whether the drug discovery plays, and predictive analytics and image analytics plays a very, very vital role in this. All right. So how do you develop a predictive model? First, you need to define the problem. Okay, and then you need to gather the information, data. How data, what kinds of data you're going to take plays a vital role. Okay, it should be a benchmark data set. It should be a benchmark data set. And you have to evaluate it. Okay, when you take a data set, you have to select what model. Okay, when you develop your own algorithms, I always say, take at least 3 different data sets and try it on 3 different algorithms minimum. 3:3 is my ratio I always give to any researchers or students, and then you figure it out from which data set for which algorithm plays a vital role, and then you apply the model and you run your prediction of it. Okay, and you can run the prediction and you'll be able to test the models. Okay, you have to test the models. So initial data set, validation data set, and testing data set, or you can have it as a training data set and testing data set. It depends. Okay, so we have seen about the introduction. I hope you should have understood. If you have understood, you can type yes, Y on chat. Any queries also, you can put it on chat. Now I'm going to take a data set of a breast cancer data set, which is a benchmark data set for machine learning. Okay, so there are two types of tumors. All right. Okay, one is a benign tumor, other is a malignant tumor. Thank you. You're able to understand. Good students. Okay, so benign tumor and malignant tumor. When the tumor is benign, which means cells are not cancerous and it won't spread, and malignant tumor means the cells are cancerous. So I'm going to take a data set which is going to have a malignant tumor data and also benign. Whenever it is benign, which means the patient is not cancerous. Whenever the output target variable of diagnosis become M, okay, which is malignant tumor, then the particular patient is a cancer patient. Okay, so this is my data set. Okay, so when you say I'm going to take a data set contains the ID number. Okay, the diagnosis, I said M, it stands the patient is a cancerous patient. B means non-cancerous patient. The first attribute is ID, the diagnosis, and 3 and 32. Okay, from the first column, second column, from third to 32nd column, I'm going to take a 10 valued features are computed from each cell nuclei. Okay, the cell nuclei of a cancerous cell or a non-cancerous cell. It finds the radius, okay, from the center to the point on the perimeter. Second, it takes the texture. That's the standard deviation of grayscale values. It is all taken by the doctors and it is called as Wisconsin breast cancer dataset. Okay, and the perimeter of it, the area of the one cell nuclei. Okay, computed for each cell nuclei, smoothness, okay, compactness, the concavity, the concave point, the symmetry, and fractional dimension. If you see, so radius is 1, texture is 2, perimeter is 3, area is 4, smoothness is 5, compactness is 6, concavity is 7, concave points is 8, symmetry is 9, and fraction. So 10 features. Okay, 10 real valued features we have taken and it is given. Okay, and each of these are going to be taken into 3 parts. Okay, like is radius mean, radius standard error, that is radius AC, and radius worst. Okay, and then you take a texture, you will have a texture mean, texture standard error, and texture worst. So 10 into 3 different parts, mean, standard deviation, and worst. So 10 into 3 you have 30 data sets. Okay, and each of it is of type. So this is my data set. Okay, this data set has got 569 rows and 33 columns. Okay. Total number of rows of 560, 33 columns. First row is the ID of the patient. Second is diagnosis, is very, very important. This is my target variable, which will tell me with all these features whether the patient is cancerous or not. If the patient is cancerous, then this column contains a value M. If the patient is non-cancerous, then the value will be B. Okay, can you see the 10 features of mean, of radius, texture, perimeter, and this is the SC stands for standard error, the next 10, the next 10. Okay, and this is a junk value, and we will be do. I told you need to clean your data. That time we will remove this data. Okay, with this column. Okay, and this is my data set, and this is my target. So I have to. What happened? Able to hear me now? When was it muted?
Yeah. Yes, ma'am. Yeah, we have just lost you, but now it's okay.
Okay. Okay. Just now I noticed it was muted. All right. So this is my data set, and these are my features, and this is my target. So I'm going to split my data set into features and target. Okay. Now let me show you a demo on using on Colab. Okay. It is getting loaded. I showed you the data set, right? 569 rows and 30 columns. I'm taking the same data set. I'm taking the same data set. Any doubts till now? Able to understand? All right. It takes long time to load. Okay. So before it is getting loaded, okay, let me share. I told right, pandas is for Python for data analysis. So NumPy is a numerical Python. Okay, pandas is for data analysis. Matplotlib is to do the plotting. Okay, Matplotlib and Seaborn. Okay, Matplotlib and Seaborn. All right, and we are going to see about this until it is getting loaded. Okay. So NumPy, SciPy, Pandas. SciPy, it stands for Scientific Python. Okay, Pandas, it stands for, I told you, Python for data analysis. Scikit is the package for machine learning. Scikit is the package for machine learning, visualization, Matplotlib, Seaborn, Bokeh, and so much and so more. All right. And now when we start with NumPy, it is used for objects for multidimensional arrays. Sometimes you work with 2-dimension, you work with 3-dimension, or it could be even multi-dimensional arrays. Okay, and it's very, very easy to perform all types. I've told right in the starting of it, you need to work with the scientific methods. So advanced mathematical and statistical applications on those objects. You can vectorization on arrays. Okay, you can work with vectorization on arrays. So NumPy stands for this. SciPy, it is collection of algorithms like differential equation, integration, optimization, statistics. It's built on NumPy. The basis NumPy, SciPy is built on NumPy. SciPy stands for scientific Python. Okay, and pandas, I said, it adds data structure and works like table, like you'll be seeing it. Now I'm going to just load a CSV data set. All right, and then I told right, when I load a CSV into the pandas variable, it will be converted into a data type called as DataFrame. Okay, it allows to handle missing data. You can reshape, you can merge, you can sort, you can slice. What a lot of applications. Even if you work with pandas itself, you can learn. For I can give a 3 or 4 talks on only on pandas because so huge is pandas. Okay, Scikit is the another package where it provides machine learning algorithm. Like you want to work with a classification algorithm or a regression algorithm or a clustering algorithm. Classification, if you go for disease kind of application, you go in for classification. Okay, the person is diseased, whether the student pass or fail, whether the sale is won or lost. Regression is used for continuous varying variable. If you take a stock value, it is not static. And if you want to take a drug detection, okay, if you want to discover a drug, then you have to keep changing, right? So for those kind of application, you work with regression algorithms. Okay, clustering is how do you cluster it with the unlabeled data set. When you take an unlabeled data set, whether what kind of customers are there in a mall, whether in which range, how many of them spend a lot, and the most important is model validation. Okay, model validation. So we have seen about these. Okay, Matplotlib, I said it is for visualization. It's for plotting. You can plot all kinds like line plot, scatter plot, bar plot, histogram, pie chart. Okay, little more advanced visualization is only called as Seaborn. Okay, it's called as Seaborn. It's based on Numpy, but it's a high-level interface. When you take Matplotlib, it's relatively a lower-level interface. Okay, now I think it should have been loaded. Yeah. Okay, initially I'm going to, I'm going to import what are the packages side. This is for analysis, this is for scientific public work, this is for visualization, and this is also for, let me run the first 4 packages. First, we need to import the packages. I'm going to take the same data set that I showed you. All right, it takes a long time. Okay, I have my data set on my Google Drive. I'm mounting it. I'm trying to load it. I don't know why it is very slow. It should be fast. Yeah. So I'll just authorize it. By the time if you've got doubts or anything, so you can post it on chat. Takes relatively a very long time. I'll just show you a demo for 10 minutes. Yes. Any doubts? Mics, some mics are being unmuted. Okay. Okay. Once it is getting loaded, it's mounted. Retrieving my data set. You remember how many rows and columns? Anybody remember how many rows and columns I said? So my data set was of a CSV, which is a comma separated value. It's a benchmark data set, and I'm loading it by using my pandas. I'm loading into this variable data. If you see here, it's a can you see like a table like structure here? And this is called as a data frame. Okay, this is called as a data frame. Okay. So all those features are being loaded. But head off shows me.
Ma'am.
Yeah.
Ma'am, let me ask a doubt.
Yes, please.
Ma'am, what is the difference between dataset and data frame? What is the difference between data frame and dataset?
Dataset is your data that you are fetching it. Okay. It's a benchmark data set. It's you have different rows and columns. Data frames, it's a CSV file. Okay, if you open the CSV file, it's just a comma separated file. All right, this is a data set or the values that you get it from a benchmark value to train your thing. When I take my data set and load, you remember I have imported here pandas as PD. Okay, so PD, henceforth, whenever I'm going to call as PD, it is pandas. Using that, since my data type is of CSV, I'm using pd.read_CSV. I'm loading it into this variable. This is a user defined variable data. When I'm loading my CSV, that is my data set, into pandas, okay, it is the type of the data inside the variable data is called as data frame. Whatever could be there. If I take CSV and load it into pandas, it's a data frame. If I take a document, normal text document, load it into pandas, it's a data frame. To look like a table-like structure. Okay, it is a data type. Data frame is a data type. Data set is a collection of data that you use.
Thank you, ma'am. Thank you so much.
Okay. So then you take data.shape. When I type data.shape, it gives me, even if I have 20 lakhs of data, it will show me how many rows and columns. So it is 569 rows and 33 columns. She asked, right? Veda asked her doubt, what is the type of data? So this is the functionality to find the type of data. Can you find here? Type of data is data frame. Any data you take it and host it into your pandas, it is converted into data frame. So if I don't give any values in panda.head of, it will take me how much huge is my data set. The first few rows will be loaded. Okay, the first few rows will be loaded into it. All right. If I give some values, say for example, if I'm going to give 50 out of this 516 rows, the first 50 data should be loaded. Can you see here 0 to 59? I told you, remember if it is malignant or benign. Malignant means it is a cancer. So if the data types are of this values, okay, the radius mean, the texture mean, perimeter mean, okay, all the means till fractional, then all the SC till fractional, and then the worst till fractional. And I told, right, this is a junk value because I've taken it from a benchmark data set. I will, during the data cleaning, I'll remove the column of unclean. Okay, so same way, like head of, if I don't give anything in tail of last few rows, if I gave data tail of 15 of, the last 15 rows will be listed here. Okay, so data.shape I told, okay, the rows and columns. If you give data.size, it will multiply my rows and columns. I can show you. Okay. It's case sensitive. So what is the variable? Data.size. Okay, it will show me the multiplication of rows and columns. Okay, so these are my columns, and D type tells me what are the data types of each column. And also I told you machine learning can whenever you develop a machine learning model or deep learning model, your system can understand only numbers. Okay, can understand only numbers. But here you see one variable is of a character. Okay, data type is of data frame, but my values inside my data frame is of the type NumPy array. Okay, my data type of my data variable is pandas. That is a table-like structure. But if I want to access the values inside it for a statistical purpose, the type of data, so if I want to see it as data.values, will give me values of the pandas. Pandas is a structure, right, of the data type, data frame. But my values inside my pandas, listen carefully, the values inside my pandas, the values inside my data frame, if I'm going to access it, I'll be using like data.values of, and the type is called NumPy array. Okay, the values inside my data frame, I repeated, the values inside my data frame is of type NumPy array. So this is of data.values like look like. It is not a table-like structure, but for scientific purpose, I need to use this. Okay, so here we have just an n-dimensional data, one rows and columns. Okay, and if I give data.style of, okay, the same data frame, but it looks like a styling format of an HTML kind of data. All right. So usually it comes very fast. Okay. Yeah, it has been loaded. Okay, and data.describe of, okay, data.describe of, what it does, it takes only the numerical values and computes the count of value, mean of the standard deviation, the minimum value of each of the rows, where here you cannot see diagnosis because it is a text kind of value. Text kind of value does not work with this. How many ever, even if you have 20,000 columns and you have 30, 40 lakhs of data within microseconds, this function will take the description of your entire data set. So it is 569. If I go in one shot, I can know there is no missing columns here. Okay, all the data are there. Okay, and also if I want to find the minimum value, for only that I can take every column, what is my minimum value. Okay. And I can do the mean, median, standard deviation. Okay, and sample of data takes a sample of different data. Okay, so first I'm going to show you, as we have very less time. All right, so drop.na, it will drop any columns, any rows. Okay, when there is a missing values. Okay, here we are not having anything, so nothing is being dropped, because even in that we saw all the data are present. All right. So this is my data. Okay. I'm going to use, I told, right, first you have to explore the data visualization. So what I'm going to do here, the first I'm going to do a data exploration. I'm going to using Seaborn. You should have seen initially I told import Seaborn as SNS. Okay. SNS dot, I'm going to do a count plot. See, when I did a count plot of my diagnosis. So my one column has got, second column has got a diagnosis, right? So from the diagnosis, there are two variables. What is malignant? Malignant means it is cancerous. Benign means it is non-cancerous. Malignant means cancerous. Benign, it is non-cancerous. Okay. So when you take malignant, okay, I can see almost 200 people. So in my entire data set of 569 rows, the number of cancer patients are less, non-cancer patients are more. Okay, then I'm just using the hue. Okay, my target here, I told even initially my target should be my diagnosis. If these are my patterns of data, whether the patient is a cancerous patient or non-cancerous. If it is cancerous, then the value is same. If it's non-cancerous, then the value is all right. So the same data, just to have a better visualization, I'm defining the colors of it. Okay. Then in my color palette, whatever color, the color values that you give, it will be given. Okay. Can you see it's almost 300 and it is 350 around, and malignant is 200. So almost it is 569. All right. Okay, and is there anything null values are available? Nothing is null, so everything is false here. Okay, the next thing that I'm going to show you, I showed you the count plot, the first plot, and now I'm going to take data.structure.sc. Okay, SC stands for standard error, right? There is one variable, one column value is data.texture.sc. I'm going to plot it using a line plot, the values. So when you see these values, can you see here the color I've given red? If I change it to blue, whatever is the color that I need, I can give. And the label is texture SC, and the other lining styles I'm giving it. Now if I run it, so in one shot I can see my total data set is between 0 to 569. For all these 569 data, okay, how the values of texture mean differs, the minimum and the maximum. Okay, so likewise I'm trying it for another column called smoothness of SC. I've just changed the line style here. Okay, there I gave a hyphen, here I'm giving a colon. That's it. The line style changes. So this is about the line plot. The next is the scatter plot. Okay, this is the scatter plot. So how the values of in x-axis I'm taking area mean, y-axis symmetry reverse, how the data are being scattered. Okay, and now I'm going into the box plot. Okay, the next box plot in x-axis I'm taking diagnosis. So x-axis is malignant or benign. Malignant means they are cancerous, benign means they are non-cancerous, and my y-axis contains my texture. Okay, y-axis contains my texture. So when you see into these data, okay, I'm getting the range of texture mean between malignant and benign. What do you understand from this graph? Let me ask you a question. What do you understand from this graph? What do you understand from this graph? Yes, answers or chat, or you can unmute and speak. You're all there with me? Okay. So you can understand people who are cancerous have got a higher value of texture mean. Those who are non-cancerous have got lesser value of texture mean. So this is one of the important features. So when a new patient come and their texture mean, if you're going to input, then with that and different variables and the machine learning model, it will be able to say whether the particular patient is cancerous or non-cancerous. Okay. Likewise, I've taken the another variable called the same box plot. But here if I see into this data set, into this variable, that is texture mean, this is texture SC. But this is almost the same for both benign and cancer. Then I can find out this is not a most important feature to develop my predictive model. Okay, and this is another variable. It's a relational plot, rel plot. Okay, I'm taking radius mean and texture mean. So here also I can find people who are malignant, okay, who are cancerous have got a higher radius mean, and those who are not malignant have got lesser radius mean. So can you see from this graph? So these are the inference that we need to do it on. Okay, so here I'm just splitting it into one. I told it mean, standard error, and worst. I'm just taking my mean to find a pair plot. Okay, a pair plot of all these pairs between each other. Can you see here? So the radius mean, the texture mean, the 10 variables on the x, 10 on the y. So in one shot, I can see, instead of going for one by one, so I can see these are needed feature. People with this have got a higher value of concave point mean are cancerous, or others are not. Some will be overlapping on one to another. So those features are not of good feature. See, if you take this feature, it's overlapping. So I can say, and this feature is also overlapping. So texture mean is not a good thing, okay, for developing the prediction model. Now I'm going to split my data set into data target. Y contains my diagnosis alone. I'm going to drop my unnecessary. With my ID, I'm not going to find out the disease pattern or my unnamed column. I'm removing it. So all my features are in X, which is a cleaned data, and my target are into Y. And you remember I told it will not work, okay, it will not work for text data. So I need to convert my text data into my what do I say, into my digital data. Okay, into my digital data. There are many things. I'm not going to run it out right now because we don't have much time. We are almost at the end of it. Okay, so using label encoder, yeah, I'm going to convert my text data into the digital data, that is the numerical data. Now if I'm going to run it, I can see whenever it is 0, it is malignant, and benign would have been transformed accordingly. Okay, it should have been transformed accordingly. So whenever it is malignant, it is 1. So it is, whenever it is cancerous, it is 1. If it is non-cancerous, made to 0. I'm finding the correlation between all the features. Okay, from the feature selection, you can do it. All right, and now I'm splitting my data into training data and testing data. Okay. After I split my data into training and testing data, okay, so how many rows and columns? So my training set and testing set, and I'm going to use I'm going to show only one using a linear regression model. Okay, I'm developing it. Okay, the predicted value, I'm going to find the accuracy. How accurate it is, these are the performance metrics. So it is like how accurate and what are the heat maps, the true, negative, and false positive. Okay, so today that is what we have seen. What are the importance of healthcare analytics and how it is to be done. All right, how to take a data. I know I just showed you a demo. Okay, in my company we are conducting a 20-hour course for students internship. Okay, there you learn how to do everything step by step for any kind of data, and then you can develop. 10 hours you'll be doing a live project. You'll be developing a project on your own. Okay, it is called our website is cirf.co.in. So every time when the number of students batch, yesterday only I completed this image analytics course, and July 1st week we are getting this predictive healthcare analytics. That is a 3-hour course. It's open for students, staff, corporate, anybody. All right, July 1st week. Okay, July 1st week it will be coming on, and this is for one exclusively for students. 20 hours workshop. Okay, hands-on training, internships for students, and then 10 hours they'll develop it. And our company is a Section 8 company registered under Ministry of Corporate Affairs, and you'll get a certified certificate about data science using Python or machine learning. Okay, so you can check out my website. If you are interested, you could join it out. Okay, now we are going to play a simple quiz. I told you I'll put the link, okay, link of the quiz on the chat. Just click the link. Okay, just click the link. And then you can join in. Pasted it here. And when you click the link, you need to give your name. Okay, you need to give your name. And so today we have started with data science using Python. Okay, what we can do. Okay, what are the different packages like Numpy, SkyPy, Matlablib. Okay, Matlablib, and we have seen how each of them are used for numerical Python, for analyses. All right, and for scikit-learn is for machine learning. Okay, scikit-learn for machine learning. Okay, I will share the link on the chat. Okay, quickly you can just click the link and you can join soon. Okay, it's posted on chat. Yeah, just click the link. Yeah, one of you have come. Ah, many of you have come, and nice to see. Yeah, 52. It's very slow. For YouTube viewers also, I'm posting it on the chat. I hope you could have got it. Okay, let me start now. Okay, my screen is not shared. I'll share. Just give me a second. I hope everybody you're there. We'll start it. So, okay, yeah, 70 of you have joined. Yeah, still joining. Okay, I hope you should have given your name. Let's see who's going to win. Answer fast. Which tool is used to generate charts? Okay, which tool is used to generate charts? Numpy or Pandas or Matlablib? Yeah, 34 answered, 39 answered, 42 answered, 49 answered, 3, 2, and 1, 64, 65, 66 answered. Yes, the right answer is Matlablib. Numpy is for numerical analysis, Pandas for analysis. Okay. Data analysis, Numpy, I told Numpy, SkyPy for data visualizing for generating chart. Let's see who's first on the 17th. The fastest is Vajitha. Okay, second is Sabik, and third is Renee. I don't know whose metal, they have not given their name, so it will take its own name. Let's see the second question. Simple questions. Few seconds. Which function is used to find number of rows and columns in pandas? Which function? Is it shape of or size of or type of? I showed the demo of all the three: shape, size, and type. To know the number of rows and columns in Numpy, we saw in breast cancer data set, we saw, right? 569 rows and 33 columns. Size, it makes multiplication of rows and columns. Only shape, it shows the number of rows and columns. I showed the demo of both. All right. First place is Anuchand. Second is Renee. Third is Saguna Engel. And the fastest is Michelle. Michelle is fastest in the second round. Let's move to the third question. After the 5 questions, it's a cumulative score which will tell us who is going to be the winner. The third question for the day. What is the data type of the data loaded on pandas? Listen carefully. What is the data type of the data loaded onto the pandas? Is it CSV or DataFrame or TSV? Very simple question. Forty-four of you have given the right answer, and you're excellent listeners. Renee is the fastest. Anuchand is on the first place, and the third place is Sabik. We'll go on to the fourth question for the day. Prediction model is developed by, how do you develop a prediction model? Using data scientist or data analyst or none of the above? In the first slide I showed who develops the prediction model, whether it is data scientist or data analyst or none of the above. Some of you also answered you want to become a data analyst, you want to become a data scientist. Let's see, 26 of you have given the right answer, it is data scientist. The last question, let's see who's topping it on this fourth question. I think Anuchand is very smart. Okay. Aminath is the fastest. First place still taken by Anuchand. Second is Sabik. Sorry, not Sadiq. Sabik, and third is Renee, and fourth is Aminath, who's the fastest. This question is going to define who's going to be the winner of the day. All right. Which Python package provides machine learning algorithms? NumPy or Pandas or Scikit? Machine learning algorithms. NumPy, Pandas or Scikit-learn? Yes, it's 23 of you have given the right answer. It is Scikit-learn. NumPy for numerical analysis, Pandas for data analysis. Okay. Given the right answer. Let's see who's going to win. So B is the fastest. It's Anuchand. Okay, what's the next question? Your feedback about today's session? How was your today's session all about? I changed it. It is not showing. It's excellent. It's good. Yes. Nice one. You learn something new. What are the new words that you learned? That also you can post. You can post it multiple times. It's worthy for us. Thank you. Awesome. Gorgeous. Interesting. Super good. Don't have words. Thank you. You can also post what are the new things that you learned today. It's 42 of you have given your answer. Nice to have you all. Okay. Very superb, clear, wonderful. Thank you. Okay, now this final question doesn't have marks. Okay, it doesn't have marks. It is going to take who's going to be the winner of the 5 questions. Yes, the winner of the day is Anu Chand. Congratulations, Anu Chand. Sabik, second place, third is Chennai, fourth is Deepak, fifth, I don't know, and it goes on. I'll share the entire event is also streamed onto my YouTube channel. You can find it out, and also I will share my contact details. So if you are interested or you want to learn more about it, or you could contact me. Okay. So this is my channel ID. It's on my system with a lot of applications. Okay. And today's event also I'm streaming it online. I'll post it onto the chat. You can get it. Thank you all for joining. I'll share my contact details too. Okay. I hope the session would have been of use to you. Yes, Anu is here. You can share your experience. How was the stuff? Because you are the winner of the day. Okay. You are the winner of the day. Just you can share excellent talk. Thank you. Okay, I'll share my details on the chat. Also, you can get it. Anu is here. I'm presenting on screen. Over to the organizers.
Thank you, ma'am. It was really a wonderful session. It's a really great informative session. We had over here just maybe 1 hour and 15 minutes. It was really great session. Thank you, ma'am, for your valuable time. Really, all-hearted thanks on behalf of IEEE Malabar subsection and my IEEE Malabar Hub and ME Engineering College Student Branch. I would like to thank all the participants who has joined over here. I'm posting the feedback form in the chat box. I request all the participants, please ensure you have filled the feedback form to ensure your participation certificate of the webinar. I would like to thank Doreen ma'am to joined over here despite of the busy schedule. Thank you, ma'am. Thank you a lot for joining with us and sharing your valuable experience and information with all. Hope all of us have enjoyed the session very well. I thank Dr. Sabik PV sir for giving us an opportunity, and I also thank all the team of subsection, Malabar subsection, Malabar Hub, and MEA Engineering College Student Branch. And I thank all the participants over here, and we love to have more sessions from ma'am, and we are all waiting for that. Thank you, ma'am. Thank you everyone for joining. And I request all the participants and everyone join over here. Please stay home and stay safe. Let's win this war together. Thank you all.
Thank you. Thank you. Thank you, sir. And thank you all the students. God bless you. Bye-bye.
Thank you, ma'am.
Thank you.
I request all.
Thank you. Those who have joined on the YouTube, thank you for joining. Hope this should be of use to you. Bye.